When a heavy lift grinds to a halt and the bar suddenly drops, you assume you've reached the absolute physical limit of your muscle tissue. Your arms shake and your chest burns, creating the precise sensation that your localized muscle fibers have been fully exhausted. In reality, this sensation is a neurological construct. Your muscle tissue remains capable of producing force, but your brain has engineered a shutdown to protect the joint. This protective shutdown is known as spinal decoupling. By severing the neural drive mid-contraction, the spinal cord prevents the motor cortex from accessing your highest threshold muscle fibers. These are the type 2X motor units, the massive fibers responsible for absolute strength that the nervous system keeps in reserve. This mechanism evolved to prioritize tendon and joint safety over maximum power, as recruiting these fibers generates enough tension to risk mechanical failure of the connective tissue. Pushing harder won't change this outcome. To access that hidden strength, you must bypass the neurological governors enforcing the decoupling. To understand how to bypass these governors, we have to look at the baseline architecture the brain uses to select muscle fibers. This selection process follows a universal biological rule, Henneman's size principle. Henneman's principle dictates that for any task, the brain activates the smallest, slowest twitch motor units first. The progression only moves to larger, stronger units when the force requirement increases beyond the capacity of the smaller fibers. This sequential recruitment conserves energy and provides precision for fine motor skills. Reaching the largest units requires an unbroken wave of neural drive. However, internal regulators cut that drive before reaching the type 2X threshold. Lifting heavy weight is often insufficient to overcome this, because these regulators are designed to trigger a shutdown the moment tension peaks. The first of these regulators is located away from the muscle belly, deep within the musculotendinous junction. This is the Golgi Tendon Organ, or GTO. Physically, the GTO consists of encapsulated, braided collagen strands that sit in series with your muscle fibers. It functions as a continuous tension sensor, monitoring the load exerted during a voluntary contraction. When tension reaches a dangerous level, the GTO triggers autogenic inhibition, sending an inhibitory signal that forces the muscle to relax. Think of this as an emergency brake that hyperpolarizes the alpha motor neuron, stopping the contraction before the tendon can be damaged. The second barrier is located even deeper, within the ventral horn of the spinal cord itself. These are Renshaw cells, inhibitory interneurons that act as a localized filtering system. Their role was identified through mid-century neurophysiological research, which isolated how these cells regulate spinal circuits. Renshaw cells create a paradoxical loop. As an alpha motor neuron fires to initiate a contraction, it simultaneously activates a Renshaw cell. The Renshaw cell then immediately sends an inhibitory signal back to that same motor neuron, suppressing its output. This self-regulating negative feedback loop is known as recurrent inhibition. Together, the GTO and Renshaw cells form a central regulatory barrier that strictly caps your maximum force output. To access your type 2X fibers, you must utilize a specific physiological exploit to bypass these spinal locks. This override is based on Sherrington's principle of irradiation. This principle was first established by Charles Scott Sherrington, a foundational figure in modern neurophysiology. It describes how an intensely working muscle creates a neurological overflow, stimulating and recruiting neighboring muscle groups. This was originally a clinical tool in proprioceptive neuromuscular facilitation, used to help stroke patients generate movement by flooding their nervous system with signals. In strength training, we use this clinical concept to create a direct bypass of the spinal governors by generating maximal tension at the distal extremities. By crushing the barbell in your hands as hard as possible, you trigger an irradiation cascade that flows up the arm. This extreme grip tension propagates an excitatory cascade that travels through the forearms and into the biceps, triceps, and deltoids. This overflow automatically screws the humeral head into the socket, creating the proximal joint stability the brain requires to permit higher force. As this wave reaches the spinal cord, the nervous system is bombarded by a combination of high-frequency signals and simultaneous neural drive. This overwhelming combination of distal drive and proximal stability forces the nervous system to reevaluate its safety thresholds.
In response, the nervous system down-regulates the sensitivity of the Golgi tendon organ. Simultaneously, the recurrent filtering of the Renshaw cells is dampened, allowing the alpha motor neuron to fire at its true capacity. By intentionally flooding the spinal cord with grip-mediated tension, these protective barriers are systematically bypassed. To apply this in the gym, you must adopt a specific training protocol that prioritizes grip-mediated tension. We can see the difference when comparing a standard open hand grip to a maximal isometric thick bar grip. This data shows how the diameter of the implement you are holding fundamentally alters spinal excitation. A standard grip requires less torque, resulting in localized irradiation. This leaves the GTO highly sensitive, causing type 2X recruitment to be truncated by early spinal decoupling. Thick grip training, however, demands maximal torque to prevent the bar from slipping. This drives the global irradiation needed to suppress the spinal governors, allowing for prolonged type 2X recruitment. On every heavy compound lift, you must abandon passive habits and attempt to crush the implement. If you fail to generate this distal tension, the nervous system will inevitably quit before the muscle tissue reaches its capacity. Physical optimization is not a matter of fighting the muscle, it is a matter of commanding